Hey everyone, welcome back sa aking channel. So in this video lesson, we will discuss continuity and discontinuity. Okay, so let's start. So continuity, let us define first. So continuity, a function f of x is continuous at x equals a if and only if the following three conditions are satisfied. So number one, f of a is defined. Limit of f of x as x approaches a equals L exists and L is equal to f of a. So kailangan masatisfy lahat yan para masabing continuous at x equals a ang isang function f of x. So a function f of x is said to be continuous in an interval if it is continuous for every value of x in that interval. The graph of this function is unbroken over that interval. That is, the graph of f of x can be drawn without lifting the pencil from the paper. So syempre, pag sinabing continuous, dapat walang putol. So nakalagay dyan is unbroken. Okay, so example number 1. Okay, so example number 1, so we have the graph of, this is the graph of y equals, this is the graph of y equals x squared. Ayan, parabola that opens upward. So the function y equals x squared. So we have here 0.24. So the function f of x equals x squared is continuous at x equals 2 because limit of x squared as x approaches 2. So limit of x squared as x approaches 2 is equal to 4. Okay, so we have, if x equals 2, the value of y is 4. So f of 2 equals 4, and also the limit of x squared as x approaches 2 is 4. So sa right side ng 2 approaches siya dito sa 4, and then sa left side naman approaches din sa 4. And the value of f of 2 is also 4. And as you can see, the graph is unbroken. So meaning dire-diretso siya. So dire-diretso yan, upward. And dito rin, upward yan. So from negative infinity up to positive infinity, so the graph of y equals x squared is continuous. Okay? So in fact, it is continuous for all finite values of x. So in the interval negative infinity up to positive infinity, so the graph is continuous. Okay? So another example, number 2. So we have the graph of y equals 1 over x. So this is the graph. So as you can see in the graph, so if we have this point 3, if x is 3, if we substitute x equals 3 in our function g of x, so we have g of 3 is equal to 1 over 3. So that is g of 3 is equal to 1/3. Okay? So kita natin sa graph, ito yung value niya. G of 3 is 1/3. So the function f of x equals 1 over x is continuous at x equals 3 because limit of 1 over x as x approaches 3 equals f of 3 equals 1/3. So limit from right, ayan, so as we can see in the graph, so limit from the right of 3 approaches 1/3 and to the left is approaches 1/3 also. Okay, so it is however discontinuous at x equals 0. So as you can see in the graph, so we have here the broken line. This is the asymptote of the graph 1 over x. So the function is said to be discontinuous at x equals 0. Since x equals 0 is the asymptote, it will never touch the y-axis or x equals 0. Limit of 1 over x as x approaches 0 is equal to infinity. So we call this the infinite discontinuity. Okay? So this is the, because if we substitute x equals 0, the value is undefined. 1 over 0 is infinity. So this is an example of a discontinuous function. So we have discontinuity at x equals 0. Okay, so next example. The graph of the function contains a break. Yan. So makikita natin, the graph of the function contains a break at x equals 0. So we have two parts of the graph, from negative side of 0 and then positive side naman sa 0. Okay, so another example, if we don't have the graph, so we just given, is the function f of x equals 4x over x squared minus 4 continuous over the interval 0 to positive 5? So if the given is just equation, or ayan, we have a rational function. So if the given is rational function, we can solve the discontinuity by solving the zeros of our denominator. Because number divided by 0 will give us undefined. So therefore, solve for the 0 of the denominator. So we have x squared minus 4 equals 0. So solve for x. So we have add 4 to both sides. So we have x squared is equal to positive 4 and then extract the square root of both sides. So we have x is equal to plus or minus 2. So therefore, the function is discontinuous at x equals 2 and x equals negative 2. So therefore, it is not continuous in the interval 0 to 5 because of this. It is not it has discontinuity at x equals 2. Okay, so the answer is no. Discontinuous siya at x equals 2. So this is the graph of the function. If we draw the graph of this, ayan. So it has discontinuity at x equals negative 2 and x equals positive 2. So these are the infinite discontinuity. Okay? Okay, another example. So we call this discontinuity as infinite discontinuity. Then we have other types of discontinuity. So we have jump discontinuity and removable discontinuity. So this is called jump discontinuity because as you can see from yan, sa left natin, so from this point, nag-jump siya papunta dun sa taas. So we call this jump discontinuity. And then for removable, it's called another term for this is hole discontinuity because there's a hole. There's a hole in the graph. So it's almost continuous except for this hole. So we call this a removable discontinuity. So if this point napapunta dun sa taas, then magiging na siyang continuous na siya on negative infinity to positive infinity. But there is a hole kaya siya removable discontinuity. So we have for jump discontinuity, the limit of f of x from the left is not equal to the limit of f of x from the right of A. So they have different limits. So because from the right the graph so makita natin sa graph, ito yung from the right of A, so approaches this point. So ito yung katumbas niya sa Y, and then from left of A or x sub 0, so this is the value of Y. Ayan. So therefore, ayan. So magkaiba sila ng limit. Then for removable discontinuity, so mapapansin natin if this is A or x sub 0, so they have the same limit from 0 from the left of x sub O or A, and then from the right they have same limit. Both approaches approaching this value. Okay? But at f of a, it is, but the value of f of a is, ito, magkaiba. Okay, so in symbol, we have limit of f of x from the left equals the limit of f of x from the right, but the value of f of x is not equal to f of a. So that is why this is discontinuous at x equals x sub 0 or x sub a. Okay, so we have three types of discontinuity: the jump, removable, and the infinite discontinuity. Okay, so example number 4, find the value or values of x for which the function is discontinuous. So if discontinuous given the equation, all we have to do is solve for the 0 of our denominator, because at x equals 0, we know that any number except 0 divided by 0, the answer is undefined. So therefore, this four rational function has discontinuity. So just has infinite discontinuity. Okay? So just solve for the zeros of the denominator. So for let's write letter A, letter B, letter C, and letter D. So solve for the function value or values of x for which the function is discontinuous. So for letter A, just solve the zeros of the denominator. X minus 5 equals 0. So therefore, add 5 to both sides. So therefore, x is equal to 5. Okay? So therefore, the function y equals 3x over x minus 5 is discontinuous at x equals 5. Okay? So for letter B, so just solve for the 0 of the denominator. So ignore lang natin yung numerator. Just solve for the 0 of the denominator. So we have x squared minus 8x plus 15 equals 0. So we can solve this by quadratic formula or by factoring. So let's try factoring because 15 is factorable. We have x squared. The factors are x and x. And then factors of positive 15 that will sum up to negative 8. So that is, we have 15 and 1. We have 5 and 3. So those are the pairs of factors of 15. So this is negative. So that means the answer is both negative. So if we have negative 5 and negative 3, the sum is equal to negative 8. So therefore, the factors of this, x squared minus 8x plus 15 equals 0, are x minus 8, x minus 5 and x minus 3. Then solve for the 0. So we have x minus 5 equals 0, x minus 3 equals 0. So therefore, the zeros are, add 5 to both sides, x equals 5, and then add 3 to both sides. So therefore, the function has discontinuity at x equals 3 and x equals 5. Okay, so another example for letter C, so just solve the 0 of the denominator, x cubed minus 3x squared plus 2x equals 0. So solve, just factor. So we have, all the terms have x, so factor out x. So we have, just subtract 1 to the exponent. So we have x squared minus 3x plus 2 equals 0. So therefore, one of the factor is x equals 0, and then solve for the other factors. So we can use factoring. X squared minus 3x plus 2 equals 0. So we can factor. Okay, so we have factors of x squared, x and x. Factors of positive 2 such that the sum is negative 3. So we have negative 2 and negative 1 equals 0. Then factor, equate each factor to 0. So we have x minus 2 equals 0 or x minus 1 equals 0. So solve for x. So add 2 to both sides. So we have x equals 2. And then add 1 to both sides. So we have x equals 1. So therefore, we have three discontinuity in this function, x plus 3 over x cubed minus 3x squared plus 2x. Okay, so again, these are the asymptotes, or these are these functions has infinite discontinuity at these values. So for letter D, so we have 2 to the x minus 8 equals 0. So solve for x. So this is exponential. So add 8 to both sides. Add 8 to both sides. So therefore, we have 2 to the x equals 8. Then express 8 as we can express 8 as base of 2. So therefore, we have 2 to the x equals 8 can be expressed as 2 cubed. So therefore, x is equal to 3. The answer, x equals to 3. So it has discontinuity. This function has discontinuity at x equals 3. Okay, so that's how to find the discontinuity of a rational function. Just solve for the zero of the denominator. Okay, another example, number 5. Last example. So find the values of the constants c and k that make the function continuous at negative infinity to positive infinity. When we say continuous at negative infinity to positive infinity, so dapat ang graph niya is dire-diretso from negative infinity to positive infinity, wala dapat break. So sa piecewise function, para para maging continuous sa piecewise function, kailangan yung dito natin parehas dapat ng value. So nahati ito sa dalawa, ang hati natin is 4. X is less than or equal to 4 and x is greater than 4. So dapat ang value nila ay maging parehas para pag ginrap natin sila ay walang break or continuous dapat. Okay, so therefore isa-substitute lang natin ang 4 sa bawat subfunction and ang values nila ay dapat maging equal. Okay? So at this interval, x is less than or equal to 4, substitute 4 to 3x plus 7. So we have f of 4 equals 3x. This is 3x plus 7 less than or equal to 4. So we have f of 4 is equal to 3 times 4 plus 7. So that is equal to 3 times 4. So that is 12 plus 7. So therefore, we have 19. Okay? So kailangan 19 din ang maging value dito sa kx minus 1. So that maging continuous sila. Kasi dapat parehas dapat yung endpoints. Yung endpoints dapat ng dalawang subfunction natin ay mag-equal para pag ginrap sila, magiging continuous dapat. Okay, so let us solve the other function kx minus 1 when x is greater than 4. So substitute, we have f of 4 is equal to kx, k times 4 minus 1, dapat equal siya sa 19. So equate this to 19. Then solve for k. So therefore, we have 4 times k. So we have 4k minus 1 equals 19. So solve for k. So add 1 to both sides. So therefore, we have 4k is equal to 19 plus 1. So we have 20. Finally, divide both sides by 4. So therefore, k is equal to 5. So the function, this piecewise function, to be continuous on the interval negative infinity to positive infinity, the value of k must be positive 5. Okay? So para mawalan ng break, kailangan parehas sila ng value. Okay, so let's try to solve another example. So we have three subfunctions. So baka hindi magkasya, lagay natin itong mukha ko dito sa kabila. Ayan, dito na lang. Ayan, nasa gitna. Ayan, so para kita nyo ako. Okay, so next for this, just substitute the endpoint. So we have 1. Substitute. So we have 1 and 4. Okay? So substitute f of 1. So evaluate natin f of 1, f of 1 din dito, and then f of 4. Okay? So isa-isahin natin bawat subfunction. So we have f of x equals x when x is less than or equal to 1. So therefore, we have f of 1 is equal to 1. Okay? So this is for the first. So we have f of 1 equals 1. Okay, so next subfunction. Next subfunction, we have f of x equals cx plus k. So this is for x is between 1 to 4. So for this to be continuous, the value of f of 1 should be equal to 1. Okay? So let's substitute. So therefore we have f of 1 equals c times 1 plus k should be equal to the value of f of 1 is 1. So this should be equal to 1. So let's just simplify. So therefore we have, so sulat natin dito ang equation natin. So we have c plus k equals 1. So that is our equation number 1. Okay? So next, for the last subfunction, so we have f of x equals negative 2x when x is greater than or equal to 4. Okay? So when x is greater than or equal to 4, so we have f of 4 is equal to negative 2 times 4. So that is equal to f of 4 is equal to negative 8. Okay? So now, so that the function will be continuous, we will solve again from the second part, cx plus k. We will substitute f of 4 and then it should be equal to negative 8. Okay? So substitute ulit natin f of 4 and then equal to negative 8. So yung kanina kasi ipaparehas dapat natin dito yung unang subfunction natin, ito yung pangalawa, ito yung pangatlong subfunction para maging continuous sila, dapat pare-parehas yung endpoint. So dalawang beses tayong magsa-substitute dito sa gitna. Yung una equal dito sa 1, ito yung sa taas. Pangalawa naman yung dito sa baba, negative 8. Sa substitute ulit natin dito sa panggitna, dapat yung endpoint niya is negative 8 din. Okay, so we have, magkakaroon tayo ng system of equation. So let's evaluate f of 4 nitong gitna. So f of 4 is equal to c times 4 plus k, and that should be equal to negative 8. So let's simplify. So we have 4c plus k equals negative 8. So tapat, ayusin natin dito. So we have 4c plus k equals negative 8. So these are our equations 1 and 2. So isa-solve natin ang c and k. So equation number 1, equation number 2. So solve for c and k. So we can solve by elimination method. So if we subtract this, we can eliminate the value of k. So subtract, so change the sign, negative, and then this negative will become positive. So when we subtract that, so we can solve the value of c. Okay, so therefore we have the value of c, we can cancel this. So c minus 4c, that is equal to negative 3c, equals 1 plus 8, that is equal to 9. So divide both sides by negative 3. So therefore, the value of c is equal to 9 divided by negative 3 equals negative 3. Okay, so if c is negative 3, then continuous na itong dalawa. So ito naman kabila, solve for k. So just substitute c in equation 1 or equation 2. So let's substitute in equation 1. We have c plus k equals 1. Therefore, substitute c equals negative 3. We have negative 3 plus k equals 1. And then add 3 to both sides. So cancel this. So therefore, k is equal to 4. Okay, so that's the final answer. The value of c is -3, and the value of k is 4. So therefore, the function, the subfunction, the middle subfunction should be -3x plus 4 so that the function is continuous. Okay? So when we draw the graph of this piecewise function, continuous na itong dalawa. At k equals 5 for letter A and C equals -3 and K equals 4 for letter B. So again, para maging continuous at -infinity to +infinity, the endpoints of the subfunctions must be equal. Okay, so that's why for letter A, we have both equate to 19. And then for letter B, since we have 3 subfunctions, so substitute natin solve yung dalawang, yung una at saka yung pang-last, solve natin. Then yung value niya for the first part, we have f of 1 equals 1, and then second part, f of 4 equals -8. Then substitute natin yung gitna, dalawa dapat dito. So f of yung endpoints 1 and 4 equal dapat sa 1 and -8 respectively. Okay, that's all. So I hope nagustuhan yung aking explanation tungkol sa discontinuity and continuity. So see you on our next tutorial. So bye-bye and God bless.